Hey everyone, good evening. I welcome you all to my talk on Frontend Observability Odyssey. Today I'm going to take you through a journey, a complex journey having telemetry, monitoring, and real-world debugging. My aim is that by the end of this talk, you should be able to tell what is a truly observable web application. Okay, so before we start, here's something about me. So I am a software engineer with 9 years of experience building large-scale front-end applications. I currently work as computer scientist 2 at Adobe. Beyond coding, I love teaching and dancing, and I had the privilege to teach around 1,000+ developers and help them up-level their skills. And I live by the simple philosophy that I teach what I know and I learn what I don't. And today I'm going to teach you all whatever I know about front-end observability. Wait a second, incident? Just a second, that's not supposed to happen. Let me just check. Okay, I think I have a production issue detected. Okay, I'll have to solve this, guys, first, please. Smoke test failed, checkout flow 87. Okay, this is serious, guys. Just give me 2 minutes. Let me begin the investigation by checking my APM. Okay, I see cannot read property ID of undefined. How many times have you seen this error? How many times? Okay, location checkout button. Okay, I got the file name. Okay, I have the browser version just in case I need it. I check my deployment logs in Jenkins and I see there's a feature add promo code. Okay, let me see what that code does. The optional chain is not there and we are not handling the empty cart items. So yeah, that's what I have found the issue. And now let me deploy the fix quickly so that I can get back to my talk. Yeah, phew. Fix is deployed and time to resolution 3 minutes, I think less than that. And customer inspect at 0. And I apparently saved $45,000 on a fake incident. But yeah, so what just happened? We caught and fixed a critical bug under 4 minutes. Let that sink in. Before the customers noticed. That is the power of front-end observability. I hope I have your attention now. So you might be thinking, what is smoke tests? I just showed you, right? Smoke tests were failing. What is it? So those are basically automated UI tests which run periodically on the critical flows. You can use any of the framework like Cypress or Playwright to run those. Here is an example with Cypress where I'm testing the checkout flow, the alert which came on. Okay, and do not confuse this with end-to-end tests. End-to-end tests run everything and test everything. Smoke test I use for testing the critical flows. Okay, so in today's journey, I'm going to cover what is observability, why do we need it, and what happens if we don't have it. Telemetry types, metrics, events, logs, and traces. Then telemetry architecture, OpenTelemetry, and demo of tools, Grafana and Sentry. So let's first understand observability. Okay, how many of you know the difference between monitoring and observability? Okay, no one? Okay, good. Get ready. Okay, there's someone. Okay, so for the others, get ready to be enlightened. So basically, monitoring helps us see the metrics that we have set. It helps us alert on thresholds and it tells what happened. Observability lets us explore unknown issues. It gives us deep insights into what is actually happening in our application and it answers the question why it happened. So in short, monitoring tells you when your house is on fire and observability helps you find what started the fire. I hope now it's clear. Why front-end observability? Why just not have it on our backends? Like there are thousands of services running. Why do we need it on the front end? So let me help you understand the pain of front-end developer. Any back-end developer over here? Any? Okay. So I have a question for you. So you would serve your service, you would add your service to some kind of a service like AWS EC2, right? If 100 people are using that, your web application, they are going to run their backend on the same AWS EC2. If 1,000 people are doing it, Again, it is going to run, you will have some load balancing and other stuff, but it will still run on the same AWS EC2 which you have configured. You know the RAM, you know the specification of it. But that's not the same on front end. We have a lot of environments. We have infinite environments. Your backend might be complex, but real unpredictability lies on the client. We have like thousands of, not thousands, but hundreds of browsers, different devices, okay, and then different screen size and different networks. We can never predict on which day some person chooses to use 3G network or a Safari browser. We can never predict that. Invisible errors, the errors that happen specifically on so devices, and perceived performance. Your API might be fast. It might be like 50 milliseconds or stuff. But if the user is still seeing spinner for 3 seconds, that's an issue. And your backend cannot catch that. So we understand what is real user monitoring. This monitors actual user sessions, not your high-end desktops or laptops that you get from your company, not your network, which is our corporate network, high-speed network. It's actual user sessions. And following categories is what we cover, like performance, like core web vitals, errors, JS exceptions, business metrics such as user journeys, context, device, network, and all those kind of things. And remember, you can only truly optimize what you can measure. So it's important for us to measure. Now, how do we measure? There are different telemetry data types. So there are 4 pillars of telemetry. The first one is metrics. This is basically the aggregated numerical data over time. So one of that is page load time. Okay, there can be other, like our core web vitals are also metrics, which we can aggregate over time and then measure what is it. Then events. This is like discrete occurrence with context. For example, user clicking the checkout button or user clicking on the cart button, something like that. Then logs, basically detailed timestamp records. So whenever a user does something on our app, what exactly is happening in our code, that logs tells us. And then traces, request flow across the services, your front end, your API, your DB, everything. So matrix helps us understand the pulse of the app. As I gave an example, LCP, INP, CLS, all these are core web vitals. Then you want to know the conversion rate. These are the business metrics. Then you want to know the technical metrics like API latency, cache hit ratio. So matrix helps us analyze this. And if you are interested to understand more about performance metrics, you can check out my talk on Flashport performance, which I gave on React Nexus last year. Next, understanding user journey. Events help us understand user journey. Okay, have you ever seen that you have shipped a feature, okay, and you got the mail from the manager, oh, we have shipped this amazing feature, only to know that after a couple of months, that feature has been shut down, like just another Google product. So what happened? How do you know that what happened? Why was that shut down? Why were people not using it? Well, you need to track the user journey. Track when user first interacts with the features, okay, like whether he's aware of the feature, completion rate, once he is aware of the feature, is he using it end to end? Then what are the drop-off points? What are the frictions? Why did the user stop? Okay, so events help you understand what users do, not just that, but how do they experience your features. Okay, I'll give you an example of a AI chatbot. Apparently that's what we build every day. So here we have users, let's say 10,000 users, and out of that only, let's say 67% are discovering that chatbot. Out of that, only 23% are clicking the chat button. And going down the funnel, what we realize is that only 14.5% did adopt the feature end to end. How do we know this? Using events. And let me explain how you can do that. So this is a sample event tracker class. You can use any NPM library. So basically what we cover is like details, context, basically timestamp, session ID, user ID. Then what was the href, what is the page, where exactly in the page is that person, which is given by port, and very important, user agent like Chrome, for Safari, what exactly it is. Then this is like how you track. You create an instance of that class, and you let's say if the person is in the product detail page, then he will go to product viewed and we will send this data. Okay. Next, coming to logs. How many of you use console logs as debugging and not actual debuggers? Yes, even I do that. And I would never use debugger because console log is just convenient, right? But this only works if you are debugging locally. This doesn't work when you are debugging an actual issue. You need logs from some kind of application like Splunk or something. So for that, you need proper logger. And you need to have proper context in that logs. Okay, and different levels of logs, like debug when you are doing development only, error when you need something which needs attention, and fatal when it's app breaking. Okay, now let me also help you understand what are traces. Okay, so when you make a request, the page load happens and then your API get hit. Okay, in that API, what actually is happening? First we do the auth check, then the route request, then we fetch the user data, then we get the orders, then we get the query execution. All this is happening behind the API call. Okay, but we need to know how exactly it's happening, at what time what is happening, right? So traces will help you understand that. Okay, and there are some key concepts that I would like to understand. One is trace ID, unique identifier for their entire journey request, and CCID, which is correlation context ID, links spans across your service boundaries. Now you might ask, what is span? Well, span is like sort of a unit of work. It's like a function, for example. Basically you call it, it does its work, and it just goes away. Let's understand this with an example. So here we have a parent-child span tree where we have the HTTP request. It has a trace ID which will be common across all the requests, and we have a span ID. Now it renders some React component. It has its own span ID and it's a parent ID. The parent ID is the span of the parent. Similarly, for the API call, we have span ID and parent. So I hope you get the idea, right? So this is how you implement it, and here we are using OpenTelemetry API. It's actually very simple. You create the span, it does its works, it handles the error, and at the end, finally it closes. Now, the most important part. So even if you do all these telemetry, metrics, events, logs, traces, still you need to be aware when you are breaking the threshold, right? Like what I experienced, the fake incident at the start of my talk, where there was smoke test failures. So this is what I had configured, that if smoke test success rate is less than 0.95, which is 95%, then give me an alert. That alert can come via PagerDuty, ServiceNow, Slack, email, anything. Okay, and not just that, it helps us catch issue early and avoid revenue loss. It helps us prevent SLA breaches. Okay, so how many of you know what is SLA? Okay, so I had a lot of people. How many of you know what is SLO? Okay, couple of them. SLI. Okay, no worries, I'm here to enlighten you, don't worry. So SLI is basically your service level indicator, actual metric that you are going to measure. Let's say page load time, or let's say API success rate, let's say error rate. That's the actual metric that you're going to measure. SLO is the objective, like how much this should be ideally for our application. Let's say page load time should be less than 2 seconds. API availability should be greater than 99.99%. And SLA is an agreement, is a service level agreement, so which you give to the customer when they buy your product, that if I'm not able to meet these metrics, then I will have to compensate you. Okay, it can be via credits or something. And this actually I understood when we had a CSO in Adobe, and we were involved in a call. Okay, whoever was part of the CSO. CSO is basically your customer incident. So we were involved in a call where they told us how much revenue does Adobe lose whenever these incidents happens. That helped me understand, oh my God, that your SLAs is not something that you just mention randomly. You have to maintain those, otherwise you have to pay for it. And your SLO, basically your objective, should be stricter than your SLA, because then you get a gap. So you get an alert, and before it crosses that SLA, you fix it. Okay. Now let's talk about OpenTelemetry, which is the universal observability standard. So what is it? It's a vendor neutral observability framework. It has a unified API for metrics, logs, and traces. Okay, it auto instruments. So once you configure it, it will do all the instrumentation on its own, and there is no vendor lock-in. So I'm not sure how many of you have seen that migration from one observability framework to another. Let's say you moved from New Relic to Grafana, Grafana to Datadog. If you want to do this, and you usually would want to do this to save costs, or if they have some new feature. If your instrumentation is done using OpenTelemetry, then it's very convenient to migrate to different frameworks. Okay, and this is an example, a simple example, good example where you are doing Trace Explorer and Matrix Explorer and all those stuff. Now, let me help you understand the architecture. So on our left, we have the applications like web app, React.js, your services, user service and all. Then you have your OpenTelemetry SDK. And what it does is that it auto-instruments your application. Then you have the OTP Explorer, which standardizes the data format. What kind of format do you want to pass it on? And then you have your OpenTelemetry collector, which processes and routes the telemetry to the relevant storage. Here, for example, I have taken Prometheus as a storage layer, which is a time series DB, and Jagger, which is for your distributed traces, and then there is Loki, which is Grafana Loki. Again, all of these are open source. And then it goes to query and analysis, where you actually query your data. Once you have collected data, you need to query the data. And then there are some observability platform like Power BI or something, where you want to either do alerts or see the business intelligence and dashboards. So yeah, now let's time for the demo. So first I'm going to demo the Grafana. So here there's an example of a shop, like e-commerce shop, and here we have certain metrics: TTFB, time to first byte, FCP, LCP, CLS, and let me just change the duration. Let's say last 7 days. So accordingly, it will give me the data. Like these are the metrics that I'm seeing. Okay, and let's say I want to check it for a particular page. So I'll go to cart. Okay, it will give me the cart related information. I want to, let's say, dive deep. I'll go to the route details. So now it's showing me the details for the cart page. Okay, what's the TTFB, FCP, LCP, all those metrics. Okay, and then if you want to see logs, basically you go to logs here, and we let it load. So we have certain web apps. Let's say I'm interested in this second web app. And here I have all the logs that are happening with the timestamps. If I want to dig deep, I'll just click one of them. I'll understand. Okay, this was delete HTTP method, this is the message. If I want to debug, this is really convenient. I just have to give a query, like usually POMQL or something, which will narrow down if you have the request ID or something, and it will show what happened over there. Okay, so that's your logs. Then coming down to traces. So here, let's say in this, I want to see one of the trace. So if you see here, you can see what happened across the entire request. This is your backend where it's trying to fetch articles, and then what is also doing, it's also doing auth. So if you want to dive deep, let's say you want to understand what happened here, you can click on the log, it will go over there, and you can understand what is exactly happening over there, right? So that's what your traces are. It gives you the entire structure. Okay, and I also want to show one good feature of Sentry, which is not there other places, which is replace. So what I demoed was metrics, logs, and traces, but I didn't show anything regarding events, right? So here, Sentry has something amazing which is known as session replay. If you see here, what is this most dead clicks? What does that mean? Okay, when the users have a user click that does not result into any activity after 7 seconds. So he clicked something and for 7 seconds nothing happened. Those are dead clicks. And most rage clicks, like user kept on clicking. So if you want to know like what exactly was happening, right? So I'll just click on that, and I'll just take any one of the example, and it will show me the entire session replay that the user went through. Okay, I'll just play here. It will show me the entire thing, what is happening. Okay, it's trying to create submit, but nothing is happening. I need to check my logs, I need to check my network, I need to check everything, even trace, to understand what actually is happening. And this is really helpful to debug user issues. Okay, so yeah, that's it with the demo. Going next, what are the key takeaways for today? One is that front-end observability is business critical. You don't assume that we have the backend on our telemetry, so front-end is fine. No, it is really important. I showed you why. And there are 4 pillars, and if you have all those set like metrics, events, logs, traces, you have your diagnostic toolkit ready in case there is an issue. Real user monitoring is a must. It's not a choice. You should definitely have it. Standardize your telemetry with OpenTelemetry so that whenever and if you have to switch to some other framework, then it's easy for you. Proactive alerts prevent revenue loss, not just with the demo that I showed, fake incident that I showed, but with SLAs also. And okay, I didn't want to show this, but okay. What do you now understand? What is a truly observable web application? Can someone tell me? What do you understand? What's a truly observable application? I already gave a hint by showing that slide, but if you have not seen. Rather than guessing, correct? Yeah, good. Anyone else would want to try at it? Yes, it's a lifesaver. But when do you call a web application truly observable? Sorry? You're able to practice properly. Okay, got it. Cool. Now let me show you what do I mean by it. If you can debug an unknown issue experienced by a user running version 2.1.3 of your web application on Safari 17.2 in a US West region with a slow 3G connection without deploying additional code, then and only then I would consider your application as truly observable. Okay, this should be your golden standard of front-end observability. You can read that again. Okay, any version of your application, random browser version, slow 3G connection, and you should be still able to debug that. Okay, so yeah, that's it from my side. And here is the QR code, not for UPI, but for the slides. And you can find me on YouTube, Twitter, LinkedIn. Yeah, that's it from my side. Thanks, everyone.